was this photograph from one of these orbiters. What we learned from this was that there aren't little green men on Mars. Looks like life, if it is present on Mars, is microscopic. Water is especially important for the emergence of life because it's really what life is made of. Your cells, mine, and those of essentially every living thing are made of about 70% water.
Well, you can imagine relief landing there, and then almost right off the bat, we do find evidence of water.
We humans can now peer back into the virtual origin of our universe. We have learned much about the laws of nature that control its seemingly infinite celestial bodies, their evolution, motions, and possible fate. Yet, equally remarkable, we have no generally accepted information as to whether other life exists beyond us. Mars was known as the fire star to ancient Chinese astronomers, and scientists are still burning with questions regarding the red planet. Even after dozens of spacecraft have been sent to Mars, much remains unknown about that world. Mars is the most explored planet in the solar system other than Earth. With all of our robotic visitors there, we've discovered that it is a world far too dry, cold, and irradiated to support the scheming humanoids or tentacled invaders once imagined by science fiction. But man has looked to Mars and imagined it as a home for other beings. Over the last 50 years, various missions to the red planet have sought to determine the probability of such an evolution. And our trips to Mars have opened a window into the deep past of the red planet when conditions were far more conducive to life. Meteorites discovered in Antarctica that came from Mars, blasted off the red planet by cosmic impacts, have structures that resemble ones made by microbes on Earth. Although much research since then suggests chemical rather than biological explanations for these structures, the debate continues. These findings do raise the tantalizing possibility that life on Earth actually originated on Mars long ago, carried here on meteorites. Was there any oxygen and methane on Mars? Is Mars habitable, or once was? Were there any missions to planet Mars? Before we begin, make sure to smash the like button, subscribe to our channel, and click the notification bell for more amazing videos. Around 3.5 billion years ago, conditions on Earth and Mars were similar. Both had thick atmospheres and liquid water on their surfaces. Both, in other words, had the conditions required to sustain life. And on one of those planets, life was indeed sustained. Precisely when biology began on Earth remains obscure, but by 3.5 billion years ago, a billion years after the solar system formed, it was well established there and has since evolved into the lush abundance of complex forms seen today. Mars, meanwhile, became a freezing desert. To answer the previous questions means visiting the place, if not with people, then at least with robots. And now is a good time to do so, for Earth and Mars are aligned in a way that means the journey takes less than 7 months. Mars' ancient climate and surface conditions remain an enigma to scientists. To geologists, the existence of riverbeds and ancient lake basins suggest a planet with significant rainfall or snowmelt. However, experts in modeling climate remain unable to account for the observed geology. Dr. Gaia Stuckey-DeQuay, a postdoctoral fellow at the University of Texas and lead author, said, "This is extremely important because 3.5 to 4 billion years ago, Mars was covered with water. Although scientists have discovered huge reserves of frozen water on Mars, no significant amount of liquid water has been found." Oxygen on Mars? In the Martian spring and summer, the red planet's oxygen levels spike an extra 400 parts per million, or 30% above what researchers expected to see based on the behavior of other gases in the planet's atmosphere. The oxygen spike seems to partially correlate to another gassy mystery, a seasonal ebb and flow of atmospheric methane on Mars. Though it's tempting to think of photosynthesis when hearing about oxygen in a planet's atmosphere, non-living processes are known to make oxygen on Mars, and these findings are not necessarily evidence of life. Instead, the results highlight gaps in our understanding of the red planet's surface chemistry, holes that must be filled if we are to hunt for direct evidence of past or present Martians. For now, there aren't any obvious suspects for what causes the oxygen spike. The usual sunlight-driven process that makes Martian O2 does not happen fast enough to account for such a rapid rise. So Traynor and her colleagues have focused their gaze on the red planet's surface, where there are plenty of chemicals that contain oxygen. One potential suspect is perchlorates, which are stable, toxic salts found in the Martian soil. In principle, cosmic radiation slamming into the red planet could break down perchlorates into more reactive compounds that could, in turn, release O2. But researchers say this process occurs at a millionth of the speed needed to account for the annual spike. Another possibility is hydrogen peroxide, water's unstable cousin. Used on Earth as an antiseptic, hydrogen peroxide gas is also produced continually as sunlight breaks up carbon dioxide and water vapor, ultimately making up a small portion of the Martian atmosphere. Chemical models suggest that this hydrogen peroxide can diffuse into the Martian soil and stick to particles as deep as 10 feet underground, forming a buried oxygen reservoir of sorts. Methane on Mars? Methane, the simplest organic molecule, was first discovered in the Martian atmosphere by the European Space Agency's Mars Express spacecraft in 2003. On Earth, much of the atmospheric methane is produced by life, such as cattle digesting food. Methane is suspected to be stable in the Martian atmosphere for only about 300 years, so whatever is generating this gas did so recently. Still, there are ways to produce methane without life, such as volcanic activity. ESA's ExoMars spacecraft, planned for launch in 2016, will study the chemical composition of Mars' atmosphere to learn more about this methane. Did Mars have oceans? Numerous missions to Mars have revealed a host of features on the red planet that suggest it was once warm enough for liquid water to run across its surface. These features include what appear to be vast oceans, valley networks, river deltas, and minerals that required water to form. However, current models of early Mars climate cannot explain how such warm temperatures could have existed, as the sun was much weaker back then, leading some to ask whether these features might have been created by winds or other mechanisms. Still, there is evidence suggesting that ancient Mars was warm enough to support liquid water in at least one site on its surface. Other findings hint that ancient Mars was once cold and wet, not cold and dry nor warm and wet, as is often argued. After decades of study using orbiters, landers, and rovers, scientists have revealed Mars as a dynamic, wind-blown landscape that could, just maybe, harbor microbial life beneath its rusty surface even today. 3 daring missions take aim at the red planet. The United States, China, and the United Arab Emirates launched missions to a notoriously dangerous destination for spacecraft. 3 rockets lighted their engines and set course for Mars. A trio of nations, the United States, China, and the United Arab Emirates, UAE, sent robotic emissaries to the red planet, hoping to start new chapters of exploration there. Each mission is a pioneer in its own right. The United States sent its 5th rover, NASA's most capable ever, in the hope of finding evidence of past life on Mars and collecting a set of rocks that will one day be the first samples flown back to Earth. China aims to build on its lunar exploration successes by taking one of its rovers to Mars for the first time. And the UAE launched an orbiter, the first interplanetary mission by any Arab nation, as a test of its young but ambitious space agency. It is far from a given that all these missions will make it. Mars is notorious as a graveyard for failed spacecraft. But if they do, they will substantially rewrite scientific understanding of the planet. The 2 rovers are headed for parts of Mars that have never been explored, and the UAE's orbiter will track the changing Martian atmosphere. NASA hopes that its mission to Mars, a 6-wheeled, 3-meter-long rover named Perseverance, will be the start of a much bigger journey. If all goes to plan, Perseverance will extract and store samples of Martian rocks that a future mission will one day pick up and bring back to Earth, possibly by 2031. It would be the first ever sample return from Mars. Perseverance is a car-sized vehicle packed with 7 instruments. Its main task is to collect rock samples destined to be carried back to Earth in a future mission. It will also study the planet's weather and geology, hunt for water, produce oxygen from carbon dioxide, record sounds for the first time, and test a solar-powered helicopter. Perseverance represents the best chance yet for scientists to learn whether life ever arose on the red planet. If it collects the right kinds of rock, then scientists and laboratories back on Earth might be able to tease out signatures of Martian life. Perseverance will land in the 45-kilometer-wide Jezero crater, just north of the Martian equator and in a spot that was once home to a lake and a river delta. That ancient delta offers a rich variety of geological landscapes, where Perseverance could collect many samples that might contain signs of past life, says Kenda Lynch, a planetary scientist at the Lunar and Planetary Institute in Houston, Texas, who has studied the Jezero landing site. Engineers at the Jet Propulsion Laboratory in Pasadena, California, which built the craft, have already mapped out several routes that it could take around the delta, covering on the order of 15 kilometers. Katie says the rover will do best if it first rolls around the region to survey the landscape, then returns to collect samples. Perseverance is scheduled to launch from Cape Canaveral Air Force Station in Florida between 30 July and 15 August and land on Mars on 18 February 2021. UAE's Interplanetary Hope. The aim of the mission is to collect data that will be shared freely with everyone. The HOPE probe is expected to reach Mars by February 2021. Whatever discoveries Mars may have in store for them, this mission has already given the team at the Space Center immense practical knowledge and the hope that reaching the red planet is within their grasp. The HOPE probe will study the upper atmosphere of Mars as well as monitor climate change on the red planet over a period of 2 years. HOPE's huge elliptical orbit will enable the orbiter to observe big chunks of Mars under both day and nighttime conditions, covering almost the entire planet in each 55-hour orbit. We'll be able to cover all of Mars through all times of day through an entire Martian year, says Sarah Al-Amiri, science lead for the project and the country's Minister for Advanced Sciences. The probe's visible light camera and infrared spectrometer will study Martian clouds and dust storms in the lower atmosphere. Its ultraviolet spectrometer will monitor gases in the upper atmosphere. This is the first mission that will give a global picture of the dynamics of the Mars atmosphere, says Hessa Al-Matrushi, a member of the EMM science team. The UAE is optimistic that it will provide a complete view of the Martian atmosphere during different seasons. It's a huge moment for the UAE, not just scientifically, but in terms of morale. China's Mars debut. China has ambitious plans for its first exploration of Mars. An orbiter, lander, and rover packed with 13 scientific instruments are set to launch from an island in southern China in late July. The mission, named Tianwen-1, which means Quest for Heavenly Truth, will be China's deepest probe into space. When it arrives in February next year, the mission will aim to conduct a comprehensive survey of the planet's atmosphere, internal structures, and surface environment, including searching for the presence of water and signs of life. The orbiter will operate in a polar orbit in order to map Mars' morphology and geological structure, while also using the Mars Orbiting Subsurface Exploration Radar instrument to investigate soil characteristics and water-ice distribution. It will also measure the ionosphere and the electromagnetic and gravitational fields, the new paper reported. The rover will investigate the surface soil characteristics and water-ice distribution with its own subsurface exploration radar. It will also analyze surface material composition and characteristics of the Mars climate and environment on the surface. Exploring Mars helps scientists learn about momentous shifts in climate that can fundamentally alter planets. It also lets us look for biosignatures, signs that might reveal whether life was abundant in the planet's past and if it still exists on Mars today. And the more we learn about Mars, the better equipped we'll be to try to make a living there someday in the future. All of the robotic activity is, of course, laying the groundwork for sending humans to the next world over. NASA is targeting the 2030s as a reasonable time frame for setting the first boots on Mars and is developing a space capsule, Orion, that will be able to ferry humans to the moon and beyond. Soon, in one way or another, humanity may finally know whether our neighboring planet ever hosted life and whether there's a future for our species on another world.